Hello, year 8. So today, what we're going to be doing is looking at something called covalent bonding. Okay, but just a very quick reminder before we do. Last lesson we looked at something called ionic bonding. Okay, I'm just going to quickly recap on the key features of ionic bonding. Okay, so here are your key points about ionic bonding from last lesson, which if you didn't get, you'll need to pause the video and write these down. So, atoms gain or lose electrons to become charged ions. Okay, now remember the reason they do that is because they want that full outer shell of electrons. So they'll either ditch one or gain one or two, depending on what it is, in order to do that. Ions with different charges attract each other, forming bonds. So a positive ion will attract a negative ion. They stick together like glue. And then finally, ionic bonds happen between metals and non-metals. So the example you had was sodium, which is a metal, and chlorine, a non-metal. And that gives us sodium chloride, which you know as salt, which is what we looked at last lesson. So just going back to today, can we figure out what covalent bonding is by thinking about the word? So it says in pairs, come up with as many words as you can that begin with co, said in the same way. But what does that mean? It gives you a clue to the word. So I'll start you off. Cooperate. Okay. Other words you can think of beginning with co, which, and then think about what the word means. That means working together. Ask around, maybe do a quick check on Google or something, see what you can come up with. Okay, off you go. Okay, so welcome back. So hopefully the word co you sort of start to understand means essentially working together or coming together. That's often what the word means. Okay, and the same is true in covalent bonding. Valent means available bonds, and co means coming together. So we're going to look at what that means. So you'll have to pause the video a few times in order to draw out what I'm going to show you. Hopefully it will work okay. So last lesson with ionic bonds, what we learnt was that atoms want that full outer shell of electrons, and they'll do anything to get it. They'll either lose or gain electrons so that they can have a complete outer shell. But some atoms have come up with a different way of getting that full outer shell. So let's just take the simplest atom, hydrogen. Now, as you can see, hydrogen is just one proton in the middle and then one electron going around the outside. Now, how many electrons does that first shell need in order to be complete? For those of you who can remember a couple of lessons back, is of course two. But of course, hydrogen only has one electron in its outer shell. So it somehow needs to gain another electron. So rather than steal one or become a charged ion, it's come up with another way of getting that electron. What it does is this. So take this hydrogen atom here and this hydrogen atom here, and their electron here is drawn with a dot, and their electron here is drawn with a cross, just to show that they come from different atoms, but they are both still electrons. What they do is they come together like this, and they share those electrons. So if we look at this hydrogen atom, there's its outer electron shell. It's got 1, 2, the dot and the cross. So it's got a complete outer shell. This hydrogen atom, its outer shell, also we can say has 1 and 2. So what they do is they cooperate. They come up with this method of sharing their electrons so that they can have a full outer shell. It's a very neat way of chemistry working. So firstly, I'm going to put a clip in assignment. It's not actually this clip, it's another one. I'd like you to have a quick go at that. Have a quick look at that, and then hopefully that'll give you some information that you're going to need later in the lesson. Okay, everyone, welcome back. So in assignments, there is a question sheet. And what you need to do now is have a go at the questions on the sheet. You can answer them in your book, or you can put them straight onto the sheet and print it off. And I will upload the answers at the very end of the lesson for you. Okay. Um, so that'll take you probably about 15 minutes to do the questions. Okay, then you need to come back on here and I'll go through again a few examples of how this might work. Right, welcome back everyone. So I'm going to show you an example of how covalent bonding actually works. Okay, so I'm going to start with a simple or simple-ish compound. Now, we've got the element carbon and we've got 4 atoms of hydrogen. You'll notice I haven't drawn the electrons in. I'll explain why in just a moment. Now, the compound which we can make from these 2 elements is CH4. CH and then somewhere a little 4. Okay, so here it is, CH4. Now, we need to know a few things about this. So I'm just going to move carbon into the middle, and don't forget, in a moment, you're going to have to draw this out. So that means it's got 1 carbon and 4 hydrogens bonded to it. The little 4 always goes afterwards to show that they're bonded together. So let's just think logically about this. Firstly, how many electrons does carbon have in its outermost shell? Okay, I'll give you a hint. It's in group 4 of the periodic table. Okay, it is indeed 4 electrons. So I'm going to draw those in as crosses. There they are. 1, 2, 3, and 4. Now, how many electrons does hydrogen have? Well, if you were paying attention to the last slide, it's 1 in each of its, 1 electron going around. So draw 1 there, 2 on there, an electron there, and an electron there. Okay, so what we're going to do to form this chemical CH4, here is what happens. We take our first hydrogen and it forms like an overlap just there, like that. Our second hydrogen, there, like that. Our third hydrogen, like that. And our fourth and final hydrogen, like that. Now, let's have a look at this. Let's take each hydrogen. Now, each hydrogen wants 2 electrons in its outer shell for it to be complete. So this hydrogen, 1, 2. This hydrogen, 1, 2. This hydrogen, 1, 2. This hydrogen, 1, 2. So the hydrogens are all happy. The carbon needs 8 in its outer shell to be complete. 1, 2, 3, 4, 5, 6, 7, 8. Remember, there are electron shells before it, but we just haven't bothered drawing those in for the carbon. Okay, so that is how we draw an example of a covalent bond. Okay, it's what's known as a dot cross diagram. Okay, so that's one way we can represent a covalent bond. The other way would simply be like this. We can draw in just quickly, I'm going to have to move these around in a moment, so bear with me a second. We can simply put the elements just there, like that. And then, just to show that they're connected, we would simply draw lines. So each bond is represented by 1 line. Now, there was one other thing I wanted you to notice. How many electrons are involved in, say, one bond? Okay, the answer is, of course, 2. Okay, so you need a pair of electrons to make one bond, all right? So a pair of electrons makes one bond. So actually, that's quite an important point. So I think we do need to just add that in. So one bond is a pair of electrons. Now, pause the video, make sure you've got all this down. If you need to replay this part, please do. Okay, so off you go. Right, welcome back. So what I'm going to ask you to do now is use your periodic table and see if you can draw a dot cross diagram and then a stick diagram for each of these compounds. They're covalent compounds. So you might need your periodic table just to count how many electrons are in the outer shell. So this is oxygen and hydrogen, and you're going to make H2O, water. This is ammonia, which is NH3, so 1 nitrogen and 3 hydrogens. So how many electrons are in nitrogen's outer shell? This is the tricky one. Oxygen, O2. How could you bring those together? So they've all got 8 electrons in their outer shell and can have the bonds. Okay, so pause the video and give it a go. This will probably take you about 10 minutes or so to do because it is quite tricky. Okay, welcome back everyone. So this is what you should have got. So water, H2O, just move that up there so it's out of the way. Oops. Okay, has this. So the hydrogen has 2 electrons in its outer shell, so it's happy. And remember, oxygen had 6 electrons in its outer shell. Okay, 1, 2, 3, 4, 5, 6. But if you combine it with the hydrogen ones, 7, 8, it's now got a full outer shell, so it's stable and happy. Okay, and we can represent this as a stick diagram like this. Okay, so all you would do is just show the bonds forming between the hydrogen and the oxygen like that. Remember, one bond is 2 electrons, a pair of electrons. Right, so this is ammonia, NH3 over here. So nitrogen originally had 1, 2, 3, 4, 5 electrons in its outer shell because it was in group 5, which means it needed 1, 2, 3 to bring it up to 8, that full outer shell. So this is how they arrange themselves. So what you've got is 1 bond, 2 bonds, 3 bonds. Okay. So if we count the hydrogens, they've each got 2 electrons in their outer shell, so they're happy. The nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. So it's happy. And then the nitrogen will form like this. And once again, as you can see, each pair of electrons represents 1 bond. Okay, so a pair is 1 bond. Now this was the tricky one. Okay, so oxygen has 6 electrons in its outer shell. So in order for it to get 8, it needs to form something what we call a double bond. So take this oxygen atom. It's got 1, 2, 3, 4, 5, 6. And this oxygen atom, 1, 2, 3, 4, 5, 6, because oxygen is in group 6. What they do, though, to get that full outer shell, if we count it, 1, 2, 3, 4, 5, 6, 7, 8. This atom has a full outer shell now. And then the same on this side. 1, 2, 3, 4, 5, 6, 7, 8. Now the reason this one is tricky is because to do this, it has to form what we call a double bond. 1 pair of electrons two pair of electrons. And so ultimately, we would draw it like this. Showing a double bond like that. Right, I know that's quite a lot, but I'd like to pause the video again and copy up these examples in your book because these will be quite useful. Okay, but this is probably about as complicated as it's going to get. But remember the golden rules. One pair of electrons is a bond. Okay, they're always going for that full outer shell. In the case of hydrogen and helium, it's 2, but in every other atom, usually they're going for 8. Okay, so think, how can they get that 8? Okay, so pause the video, and if you didn't quite get this, do this now, please. Okay, so we're going to finish there. Just a few extra thoughts I wanted to think about. Most organic chemistry, indeed a great deal of inorganic chemistry, most things you can see are held together by covalent bonds. So if you think about the atoms that make up your body, okay, those atoms are often held together by these incredible covalent bonds. Okay, that's a really important thing to think about. Okay, your whole body is held together by different atoms sharing electrons. That is an incredible thought when you think about it. So you get an understanding of how important this is to everyday life. Okay, so what we've done today is actually fairly advanced. So I would say now you've had a go at this, go back and see if you can complete the sheet because you will have had the video and I've now talked you through this. Okay, this should hopefully start to make sense. If it doesn't quite, don't worry, we will be covering it again in year 9, but covalent bonding is essentially the way atoms of non-metals stick to other non-metals. Okay, so that's really important. So actually, I am going to go through the key points for you. Basically, it involves non-metal bonding. It is sharing electrons to get a full outer shell, which is most stable. Okay, you can get single, double, and in some cases, some rare cases, even triple bonds. Essentially, the more bonds there are, the stronger it is held together. So an example of a triple bond would be nitrogen. Nitrogen triple bonds to another nitrogen to make N2. So nitrogen is really stable and it's really, really hard to kind of do anything with it. Okay, so that's just a little bit of information for you. I'll be online as always, and good luck.